In this video, we'll begin looking at GIS analysis in ArcGIS Pro. Specifically, we'll perform some analysis with vector data, which, as a refresher, is data which consists of points, lines, and polygons. Specifically, I want to take a look at the number of dangerous intersections we can find in each county in the state of Missouri. To do this, we're going to take the opportunity to look at some TMS data so that we can get an idea of what a typical workflow using TMS data might look like. I should caveat that the data found in TMS is not totally clean for this analysis. It's not up to date and it contains some duplicates, so we should treat this analysis as not accurate to ground truth. However, I still want to go through with it so that we can get an idea of what this kind of analysis would look like. The specific kind of vector analysis that we'll be doing is a spatial join, and we'll also do a bit of more tabular data manipulation through the attribute table. By this point, you're probably a pro at figuring out what to do when we start a new exercise. We're going to go to Insert, New Map. If you still saw the local scene icon there, you need to make sure you hit the drop down to choose a new 2D map, as we're going to stop working in 3D now and just go back to working in 2D, which is what ArcGIS Pro does best. We're going to change the name to High Injury Intersections, and our coordinate system, our familiar UTM Zone 15 North. We'll also choose a base map, and I'm going to fall back on my familiar light gray canvas and uncheck those labels. Since we'll be looking at every county in Missouri, I don't want to have any extraneous labels cluttering things up. Now let's get started adding our data. For starters, what we're going to be mapping is every county in Missouri. So what we can do is just add the existing Mo counties dataset that we've already created in the previous exercise. The other piece of data that we need to look at can be found in the TMS prod database. I've already connected to TMS prod in this particular project. If you need to remember how to do it, go back to see the Connecting to TMS video earlier in this series. Real quick, I want to show you a trick. If you find yourself using TMS data frequently, you can right-click on your database connection and choose this option with the star and push pin titled Add to New Projects. That'll give you the option to load in all new projects with this database connection already established. The data that we want for this exercise can be found under tms.high_has_intersec_data_VW. We'll go ahead and add this to our current map. After a bit of calculation time, the points for every intersection in the state of Missouri flagged as high hazard by transportation planning will show up in your map. As you can see, it's quite a number. In fact, if we right-click on this data layer and attempt to open the attribute table, we have an error. This is likely due to the simple volume of data that's present in this particular data layer. To deal with this, we need to restrict the amount of data in our layer in our map. We can do this by editing the SQL query which defines this data layer. Let's right-click, go to Properties, Source, and here under Query, we can click the pencil to edit the definition. The definition for a layer imported from TMS is created through a SQL, that is, Structured Query Language, query. A typical SQL query used in Arc Pro consists of 3 different clauses: select, from, where. The select clause determines what type of data you want to import with your layer. You name every single piece of information available in the original table, which you care about porting over to ArcMap. The from clause is the simple clause which just identifies which table you're pulling your data from. Finally, you can add an optional where clause, which we'll do now, where you can limit the amount of data coming in to only those records which meet some sort of criteria. In this case, what I want to do is look at only those intersections which have had injurious accidents of a number greater than or equal to 5. Here we'll define that via the phrase injury accident CT for count is greater than or equal to 5. This will limit the data that comes into our data layer to only those intersections which have had more than or equal to 5 injurious accidents in the study period. We can hit validate to make sure our SQL query has no errors, and then hit next to continue. Here we want to choose our unique identifier field, which is not history ID, but object ID. We'll keep our geographic datum the same and hit finish, and then OK. Now we've seriously limited the number of points that were in this data layer. Only those very dangerous intersections are now showing up. That also means that when we open the attribute table, we no longer get that error. Now we can see all intersections in the entire state as individual points. But I don't want to see individual points. I want to see a summary by county. How we're going to get from individual points to a summary by county is through a special ArcGIS Pro operation called a spatial join. A spatial join allows you to transfer information from a source layer to a target layer based on some geography that the two layers share. Let's look at how to do this. To add information to the counties layer, we're going to right-click it, go to Joins and Relates, and add Spatial Join, not just Add Join. Our target feature is the layer that we want to add information to, and our Join feature is the layer that we're pulling information from. This error is just letting me know that there's a bit of an error between the two different coordinate systems that these layers are using. That's okay. We want to leave on keep all target features. If we don't leave this on, then target features which don't get any information from the source feature, that is, counties which do not have any high injury intersections, will disappear from our result layer. We don't want that, so we're going to keep all target features. Finally, our match option defines what geometry we want to look at when transferring information from the join feature to the target feature. What we want to do is transfer all information to the county from each intersection point that county contains. So we're going to choose the match option contains. That is, the whole sentence should be read as target feature contains join feature. or county contains intersection. We can also choose this field drop down here to limit the amount of information that's being added to our county dataset. In this case, most of the information about these intersections is stuff that we don't really care about. I'm going to leave just 4 fields in the output to be transferred to the county's dataset. Specifically, I want to look at the counts of fatal accidents, injury accidents, paid day off accidents, and all accidents. I've removed every other field from this field map so that they won't be added to our county. Another thing I'm going to need to do is edit the merge rule. The merge rule is important when there is more than one join feature per target feature. In this case, more than one high injury intersection per county, which applies for a lot of the counties in our dataset. There are several different merge rules which determine what information each target feature takes based on what join features are in it. For instance, the merge rule maximum will mean that the target feature will take the maximum value of all of the join features that are within it. In this case, we don't want minimum or maximum. What we want is sum, so that the sum of the count of accidents in each high hazard intersection is added together when that information is transferred over to the counties. We're going to hit OK to perform this spatial join. That spatial join may take a while to run. Once it's done, you can go ahead and uncheck your high hazard intersection data. You don't need it anymore. And let's pop open the attribute table for our Mo counties to take a look at what we've got. You can see all of the attributes that came with our original county data, as well as a new join count, target FID, which is not important, and fatal accident, injury accident, PDO accident, and total accident counts. At this point, I should note that this data is not actually connected directly into your Mo counties layer. If you add this to another map, that data won't carry over. It's still pulling from the TMS data. If we want to make this join permanent, we need to export this data to a new feature class. We'll do that by right-clicking, Data, Export Features. Our output feature class, we'll make sure is in our working geodatabase, and we'll call it Counties Accidents. Now we can remove the old counties as well as our high hazard intersection points. All we want to look at is our fully joined layer. If we pop open the symbology pane, we can change this to draw by graduated colors and choose the field join count to take a look at which counties have the most high injury intersections. If instead we want to look at which counties have the most injurious accidents at those intersections, we can click on Injury Accident Count. But you'll notice that some counties have become invisible. That's not ideal. The reason for that can be found if we pop back open the attribute table. You'll notice that for a few counties, all of their accident counts are listed as null. Specifically, those counties that have accident counts as null have a join count of 0. That's because when the spatial join was performed, for those counties which did not have any high injury intersections, there was no data to port over. And since we chose to keep all target features, those counties were kept in our dataset, but instead of getting zeros, they got nulls. And null doesn't mean 0. What it means instead is something more like, I don't know. In this case, however, those nulls are zeros. Since these counties don't have any high injury intersections, they didn't have any accidents at high injury intersections. So we need to go into our attribute table and change those nulls to be zeros. We're going to do that with a field calculation. I'm going to show it only on the injury accident counts. The calculation would be exactly the same for every other field. We'll calculate field, and this time I'm going to use a type of Python expression known as a ternary. A ternary allows me to set a value for a particular column to be one thing under one condition and something else under a different condition. The syntax I'll use is injury accident count is 0 if join count is equal to 0. That is, if there are no highly injurious intersections, the accident count at highly injurious intersections is automatically 0. Otherwise, which in most programming languages is phrased as else, we want it to keep the same value that it already has. So we'll select the column that we're calculating into. I'll go ahead and enable undo and then apply. Okay. And you can see everywhere there was a null, there's now a 0. But all the other rows kept their original values. You can do that for all of the other accident types if you want. I won't do it because I don't want to take up the time. Instead, I'll just save my edits and we'll keep moving. If I refresh this view, you can see those invisible counties have showed back up. Now that we've almost got our display ready, we just need to choose an appropriate color ramp to display which counties have the highest number of intersections, have the highest number of injurious accidents at high hazard intersections. This color ramp is actually already pretty good. What we want to choose is any color ramp which has a red at the high end, because red usually signals bad, and more accidents, of course, is more bad. We can choose either this yellow to red or something like a white to red class. I would recommend against choosing a green to red class for a couple of different reasons. Number one is that colorblind people, who constitute about 10% of the male population and a smaller but not negligible percent of the female population, have difficulty telling the difference between green and red, whereas they typically don't have that same level of difficulty telling the difference between yellow and red or white and red. Additionally, a green to red color scheme tends to give the impression that there is some meaningful value in the middle. In this case, it would imply that we're okay with the amount of injuries present in all green counties and only not okay with the amount of injuries present in all red counties. But frankly, we're not okay with any injurious accidents. If anything, we'd like to get to 0 if possible. So we don't want to give a misleading impression by using a green to red color ramp. And so instead, we'll choose a white to red or yellow to red color ramp, which does not give the impression that there is some critical value below which we're okay. We're now ready to take the information gleaned from this analysis and apply it towards a layout. As with our previous exercises, we'll actually skip the step of making a layout here, since again, it would be more or less the same as it was with our previous county map. In the next video, we'll go on to show analysis on the other major type of data that can be used in ArcPro, rasters.